do this like calculate geometry stuff. Alright, so call to cache our flow field computed data. So we're going to call reset on ourselves, so flow field reset on both of these things. And what we're going to do is, discover flow objects is also going to be on here. Calculate. We're going to then call calculate paths, and then we're going to call this other stuff on it. So this function should be callable. From inside of the blueprint, and then we'll call the other ones on it, and I'll hook those buttons up in just a second. So create the flow field with all that. We don't want simulation ticks because we don't have them. And then what we're going to do is we're going to tick. We're going to call tick each time, and for each tick we're going to do stuff. So for each tick we're going to have particles. And where are the particles going to exist? The particles are going to where are the particles going to exist? That's a good question. Should we have them exist on the map? We don't have any of those. Like, we got the flow path, and that's not really a thing that we need. Like, I guess maybe we should stick it on the map, like the flow path map. So we'll have like, I'll just make it public for now, but we'll have like a T-array of all the particles. Maybe we should have a T-list. Yeah, I think we should have a T-list of particles. And then we're going to want a T-array of booleans for stuff that's occupied. We're going to have like collision map. So we're going to have like void tick and let's pass in a reference to the flow field. Alright, so we'll have a tick for this flow path map. And we've also got the reset for that. And let's throw that down at the bottom here. And we're also going to set this thing up. So when we initialize this stuff, This will be called detect the particle simulation. Alright, our map needs to have like some sort of initialize, so like void init and 32 width and 32 height. And the init is going to actually need to do stuff like m width equals width and m height equals height, and collision map dot init. We're going to say false, and then m width times m height. So we got it all sized up properly. Alright, so the flow path map is going to, we're going to call init on it inside of our stuff. So we'll do it right there. So we'll have it initialized. We have all of our Boolean value array stuff sorted. So what we should be able to do is then, the first thing we want to do is we want to spawn particles. Well, do we want to move particles and then spawn particles? I think that probably should. So we're going to move particles, and we'll have spawn particles. And are we actually going to use the flow field here? Yes, we are. We're going to need to reference the flow field and spawn particles. Because we're going to need to go down the line and spawn all the particles where we can actually spawn them. And we're going to need to write the particles, and we're going to need to write them to the flow field's particle colors array. So we're going to need a write particles function here. And we're going to take a t-array of fcolors reference. Starting to get light out? Yeah, Sanacron. I can see light outside my window too. But we're gonna keep going because it's only been, what, 9 hours of streaming here? I think we can keep going. There's no reason to stop. Alright, so we need spawn particles and write particles in here as well. Oh man, every time I do forward declarations, I know I shouldn't laugh, but there's this one guy I worked with who literally after like a couple weeks of messing around with project includes and crap like that in Visual Studio, he decided that forward declarations don't work in C++. Like that was the conclusion he came to. Like we're at stand up and the guy's just like, forward declarations don't work. They're just broken. And and I was just like, I mean, you can't even argue with that. You're just like, so they don't work. He's like, no, they don't work. Forward declarations in the C++ specification are broken and do not actually work properly. And I was just like, well, that's you know, obviously, that's a problem. Oh man. It's like we had one team where the guy was just, a couple guys actually were like having trouble with messages, and messages weren't getting through and called in the game from the server. And the guy's like, you know, like TCP drops packets, and I'm just like, you know what? That's not true. Like the specification for TCP is that it literally does not drop packets. And the guy's like, but we're not getting messages. And I'm like, well, there's a lot of things that could be happening other than just like the specification for TCP is a freaking liar. And he's like, nope. And I'm like, are you sure like the connection isn't dropping? And all that? And like, are you sure that you're subscribed to handling the message when the message actually appears? Or are you like getting the message and being like, oh, there's a message for creating an enemy. Oh, well, I don't have a level loaded yet. So like, let's throw that shit in the trash can. You know? And then you load up the level, and you're like, well, where'd the boss go? And be like, well, the level wasn't available when the boss spawn message came in, so like, I'm not gonna make the boss. It's like, well, crap. It's like, why don't you buffer the message based on a subscription channel? It's like, oh, what? And I'm like, ah, Jesus Christ. So that was kind of our calling card for a while there. When you're ever dealing with somebody really ridiculous and says something that's just completely false, but they're completely convinced that they're correct. You just say like, "Ah, yeah, man, TCP drops packets," and then you just walk out of the room. Attempting to reference a deleted function. What? Compiler has generated flow map path flow map here. Is it collision or is it collision map? If we have the flow path map, it's definitely collision map there. So. Reset is not a member of particles. It's a T list. Is there a reset? Is there a clear? Is there anything on this damn thing? On a container, is there like reset? Is there clear? I am very surprised that there is not a right, we need a move particles function here. I am very surprised that the T-list doesn't have a reset command on it. I'm looking at the documentation for a T-list and I don't see any. Yeah. And someone knows how to remove elements from a list. Yeah, I don't see any way to remove stuff from a frickin' list. Like, T-list just has element and next. And like an iterator. It doesn't have like a reset or... Like, we have different classes which all are aligned from this. Like, let's see, there's like bytes to hex and get data and stuff like that. Operator news, but there's no reset on it, so I don't know, like, how the hell do you remove an item from a T list? And it's like, can you? Or is there T linked list is what I should be using? T linked list. Next is linked. Is there a reset on? It's T linked list. All right, let's try that. And this thing's still going to be angry about a deleted function or whatever, probably, right? Is that going to be like some default constructor shenaniganry? He said it's not a member of T-linked list. What the hell is a member of T-linked list then? Is there like... Removes this element from the list in constant time. This function is safe to call even if the element is not linked. So if we call unlink, I mean, I guess it's just calling unlink, which would remove this element from the list. This function is safe to call. Like, this should, I guess, unlink the first node on the head of this thing, and then like that's the end of the list, right? Like, if you unlink the start of the list, then you're hosed. Your list is gone. I don't know. I'm surprised there's not like a reset and then like a next or something. This is not how the STL list works. So I'm very confused as to why they didn't follow that. Alright, so we're going to need to implement spawning particles. So what we're going to do is go down the lines. Do we have a move particles function? Did we make one? We declared one, but we never called it, so we need to define it. It's another thing, if you're unfamiliar with C++, you can declare a function, but if you never call it, the compiler does not care, and the linker will not give you an error, because it's like, I don't have anything defined. Alright, so we're going to go down the A star lines of this flow field. So we're going to like flow field dot... What are we grabbing? It's going to be these im paths. So for every calculated flow path in path, we're going to want to go from the start and go to the end and try to spawn a particle on it. Let's see. Is there a reverse for each loop? Because what I want to do basically is I'm thinking about if I'm spawning these particles and these paths are right on top of each other, then if I just spawn them in the same order each time, what'll happen is the same object will always, the same path will always spawn the particle, and if the so there's kind of two solutions. I could spawn a particle regardless of if like a collision is there, but like something's always going to occupy the space, and that's kind of a problem. And if I spawn both particles, like the order of this needs to be different. I need to have a randomized particle spawning order. Like I need to, when I spawn particles, it needs to be random which order, which path that actually spawns the particles first. So I guess we need like a int32 start index. So we can do like for int32 I equals start index, or we'll just like while true this bastard and not really care about it. So we're gonna do like I equals this like mathutils random value. Alright, so it's going to be if like it's the first iteration, skip it, and yeah, and I equals start index, then we're going to break. And this is kind of sloppy, like while true loops are just stupid, you shouldn't use them, because they're prone to infinite loop bugs and other crap like that. And anything you do can probably be done better without one, but sometimes if you're lazy and you don't give a damn, you do what I do and use them anyway because I don't really care. So if, yeah, it's going to be like at the end of this loop, it's going to be start index, plus plus. We're going to say if start index is greater than or equal to flow field.paths.num start index equals 0. And what's our math utils got for us? The index is going to be this random int range, and it should go from 0 to flow field .enpas.num -1. Alright, so that'll have a random starting index for our array, and we'll cover everything in the array. So we're going to, all along this path, we're going to spawn a particle onto our flow field. Alright, so it's going to be on the path, so it's going to be for every flow path node in path.m path. We're going to create a new particle on it. So we're going to create a new flow path particle. So we're going to make this particle. This particle needs to know its destination x and y. So int32m dx and dy. And what we're going to do, okay, so particle.m x equals node.m x, particle.my equals node.my, the particle.m dx equals the flow path. So I guess we need the flow objects we need this calculated flow path to have the start x and start y. So let's just do int32 sx sy and int32 mex and mey. And let's make sure to set those values. And these are all, we should also have like a bool here for like mFound path. And let's actually go ahead and make a constructor for this thing so we can initialize all these variables to something reasonable. So we don't get screwed by some numbers later. Alright, so just simple stuff. Harbor porpoises? Well, Lucas, harbor porpoises are porpoises that live inside of harbors. You might have seen them in harbors at some time. I hear they hang out there. Other than that, I know absolutely nothing about harbor porpoises. So I'm sorry I can't help you there. Alright, so we are calling calculate flow path with null. Let's do our calculate paths. We don't need this function anymore because we're not using it because reasons. I did the same damn thing again there with the constructor. Alright, so bool found equals this, so path.m found path equals found. So what we're going to do here is in our spawn particles, if path.m found path equals false, then we're going to continue. That is horribly... see, this is why you shouldn't use while true loops, because I would have skipped my index incrementing crap with a continue there. And that would have been, you know, as soon as I had something I didn't do that didn't actually have a path on any of our input nodes, it would just soft lock the editor, which would be really unfortunate for somebody working on stuff. So I'm actually going to set these variables here after I have clamped them properly. Alright, so we're going to have the dx is going to be the path.m ex, and particle.m dy is going to be path.m ey. Alright, our flow path particle.mLife equals just 0. We might use it. Position here history is going to be 0 and all that sort of stuff. And this tick on our particle, I don't think we're going to call it. I think we're just going to call it inside of move particles and deal with it that way. So what we're going to do is on our particle linked list, we're going to do T linked list has got a link after, link before, link head, link replace. I don't like this linked list. Is there a different linked list that has tail? Because I need tail on the linked list. So we've got linked list base, linked list. Is there like doubly linked list? Let's see, a doubly linked list. Let's see what it's got on it. It's got add head, add tail, and like all this other stuff. Okay, so okay, yeah, we want the T double linked list. It's actually got all the... Can this IntelliSense thing please get the frick off my screen? Alright, we want the linked list here because we actually have an empty function, which is, I don't like that there's an empty function because In some libraries, it's like is empty is shortened to empty. But we want to add to the tail. So we want to call add tail on this thing. Because we always want to insert particles at the end because we want to update them last. And I believe that's important. Okay, so we'll add this object to the label list. Alright, so that'll add all the particles on there. We need to check if there's already a particle in this location, and if there's a particle already in this location, we need to skip it. So we're going to look in our collision map. So if collision map sub node.mx plus node.my times, we're in the map, so this will be m width. Yeah. Then we'll continue. So, and why don't we just make a simple convenience function? Let's just call it space occupied and just pass in 32 x and y. And let's just return, our stuff here. So outside of the map is going to return true, otherwise we're just going to do x plus y and all that sort of stuff. So that should help us just write probably easier to read code instead of doing that multiplication crap everywhere. Alright, so all we have to do is if space occupied node.mx node.my. Then don't spawn a particle, otherwise spawn a particle, and we'll randomly go through these every single tick, so we're not going to bias our flow field towards one thing or the other. It's just going to equally spawn particles off of itself. Incomplete type is not allowed. Okay, let's just make sure we can compile at the moment. In space occupied, you wrote C instead of X. No, I didn't. You beat the compiler by about... let's see, 30 seconds? Alright, water flow object, unknown override specifier. Water flow object is up there. Yeah, it's because of a semicolon, not that. We got some semicolon or something screwed up somewhere here. Yeah, there it is. Both of those. Well, that's what happens when you're coding this long without a break or anything real. You just start making a lot of stupid little errors. So I might want to consider, ending at some point, because quality of work will drop. But I feel like working, so I'm just going to keep messing with stuff, even if I make mistakes. No, I'm not ending yet. I still feel like working, so I'm going to be here until I stop feeling like working. Alright, so we'll be able to write the particles and all that stuff, and we'll be able to move them here. So, let's get the writing of the particles out properly. So what are we going to do for writing the particles? What should we write to the T array? So the first thing we should do is we should init this thing to fcolor like 000 255, and then m width times m height. Just out.reset it, or whatever, we'll just initialize it. So we'll initialize it to black, and then what we should do is we want the vector direction that this thing has traveled, most likely. I don't think we need much more information than that, just the history or something. And maybe we can watch these particles. We'll see. So to get their actual vector direction and all that stuff, each one of these particles has a position history on it, which is a pair x and y. So I guess we should void fill color. Let's do fcolor reference color. So we'll have a flow path particle fill color method on this, and it's gonna figure out what color we should write. Alright, so for our position history, we're basically going to iterate over our I need to look up the documentation for T-pair real quick to see what names. Excuse me, got hiccups, I guess. Type def T tuple. So we have operator equals tuple implementation. Is there pair dot left and pair dot right or something? We have equal operators. Is it dot key and dot value? Yeah, it's dot key and dot value. The documentation is not always clear, and IntelliSense doesn't tell you. If you don't already know what that value is, it's sometimes difficult to track it down real quick. Alright, so we've got our color, we've got our stuff here, so we want like alright, so float, yeah, let's just do ax plus equals l dot key, ky plus equals l dot value, and we're just gonna Then we are going to have our actual AX and Y. So AX divide equal by M position history dot num. That's not what we want to do. We want to get the average direction that we've been moving with a bit of momentum on it. So what we want to do is we actually want to calculate the dx and dy from all these things. So we want the mx minus key and my minus that. And that'll give us our average AX and Y and all that stuff. So how do we want to normalize this? We want to just normalize this into a direction. Alright, and if all of these directions have the same weight, then we just normalize the value. Is there an f vector 2D 0 vector? Yeah. And I like to be more explicit with initializing crap just because I'm dumb like that. Alright, so we're going to say color dot, I guess R is going to be our X, so color dot R, but we need a negative value in here. So these F colors don't have negative values. Well, we'll just need to fix that. So why don't we just say color.r equals 128 or 127 minus 128 times dir.x, and this is going to be fmath 4 to int and that'll be our color. So writing particles is basically we're just going to do for every particle in our particles array, we're just going to fill color on it. And we're going to just be explicit here. Color equals out sub part.mx plus part.my multiplied by m. So that'll fill all of our colors out on our particles. Okay, so that works. So we need to actually move the particles. So how do we actually move these particles? Let's think about this for a second. What we were saying earlier was we want them to move kind of in the direction that they want to go. Let's just try it with moving in the direction they want to go. Otherwise, they just move. Like, let's do it really naively. So we're going to want to get the wanted direction to go, and then we're going to go out from there in order to do it for every particle. So and we're going to be able to move diagonally. Let's not worry about anything like that. Let's just write it as we would. So if we call tick on these things, like we just do part.tick and we pass in ourselves, like we just do this on it. Maybe we can do all this inside of the tick for this. Let's save our starting position in there. And all that. So we'll have tick get called. And we should be able to do everything we need to. So call to tick our particle. So what are we going to do for the tick? Is there any simple way to do the direction choosing stuff? Alright, so we've got our WX and WY, and we want the direction for that. And the question is, should we for our wanted direction, should we just go diagonally and all that stuff? Like, should we even care if normalizing a vector and then like figuring out like if the magnitude of the vector is more diagonal than it is down to go diagonal? Or should we just go over and around and all that? So it would be like if the start and end are like this, it would just go diagonally and then it would go straight down. I mean, the other thing I could do is model these things with like a velocity or something like that and have a velocity going straight down, and then when it collides, just, you know, rotate velocities or something, move it around. Let's see. work in the basement, there are spiders. There's one less spider. Because I don't want to code out a whole bunch of specific crap for this. I'd like to, cleverly determine like, oh, well, the starting condition is 8 or whatever, and then just rotate it around. Where like basically what I'm thinking about is how to code out this thing, and you could. So if you've got like 4 directions here or whatever, 8 directions that is. So if like this is direction 1, 2, 3, 4, 5, 6, 7, 8. So if you wanted to go in direction like 1, what you would do is say, well, I wanted to go in 1, and then if you can't, what you do is you say, well, then it's iteration 2, and so it'll be iteration 0, so you go like 1 plus 1, and then if it's iteration 1, what you do is you then try to go to 1 minus 1, which would be 8, and 1 plus 1, which is 2. And then you'd do the same thing here. You'd be like 1 minus 2, which is 7, and 1 plus 2, which is 3. And kind of do it that way. So I think that's probably what I want to do. So we want... I guess I want to get the angle of this vector and determine what it is by the x and y. And I think I have that function already written. So mathutils has got... yeah, this atan2 thing for this, and we'll get the angle from the vector. Alright, so mx, my to exey, or the m dx, m dy. So we'll get our float or angle. So if angle what are our degrees for this sort of thing? It's like 45 degrees, and then we divide 45 by 2, because math, which is going to be 22.5. So what we're going to want to do is we're gonna like int domain is going to be what? Start domain.